The human mind is a miraculous thing. The mere action of crossing a street involves processing countless bits of data, calculating unconscious probabilities, and then choosing appropriate reactions, and we do it all in a split second. In many ways, our brains are the most sophisticated of machines. But how do we do it? Answering that question has been the life's work of one particular great mind. Judea Pearl was part of the first generation to grow up in the new nation of Israel. As a young man, he served in the army and worked on a kibbutz for a year. But intellectual curiosity would lead him elsewhere.
I told the head of the kibbutz at that time that I decided to go and study engineering. He said, "For engineering? You're going to leave the kibbutz for engineering?" That was unheard of.
After graduating from the Israel Institute of Technology in 1963, Pearl moved to the U.S., where he earned a master's in physics and a Ph.D. in electrical engineering. Then he began work at the RCA Research Laboratory.
This period was really exciting. We had no doubt that any phenomena that we see exhibited by a human being will eventually be emulated by computers. And the question was only how.
Pearl carried that question with him to the West Coast, where he joined the faculty at UCLA in 1970. During his 38 years there, he developed some of the most innovative programs in all of computer science. His goal was simple, yet daunting: to recreate in machines the uncanny ability humans have to reason under uncertainty.
In every aspect of our life, we're receiving ambiguous clues from the environment, and we managed to do a fairly good job.
The first step was to understand how the mind uses shortcuts called heuristics.
Heuristic is a rule of thumb, quick and dirty rule of thumb that tells the problem solver what subtask to tackle next. We take the simple problem to guide our examination of the more complicated problem.
Next, he tackled the question of how the mind organizes such a vast amount of information. Pearl's answer challenged a long-held assumption about how our minds work.
It is impossible to imagine that the mind would have a supervisor. A much more realistic architecture is that it consists of a collection of stupid computers, or let's call them simple computers.
Gone is the analogy of the brain as one large cooperative system or computer. Instead, it seems to be the workings of a mass of tiny computers or nodes operating independently, which collectively amount to intelligence.
Each one performs a very small computation on the messages received from the neighbors, generating new messages to its neighbors in such a way that the overall picture will give you the correct degrees of belief in all the actors and all the concepts involved in the story.
Pearl's work in explaining, quantifying, and ultimately emulating human reasoning in computers has brought about a revolution in computer analysis.
Whatever people do well, computer can do better if we only listen carefully to how people do it.
That prospect may be threatening to some, but Pearl sees it differently.
I think it's only going to make our life richer, because the ability to emulate, the ability to automate, is the ability to understand. And understanding ourselves should not be threatening. It should be inspiring.
The 2008 Benjamin Franklin Medal in Computer and Cognitive Science is presented to Judea Pearl for creating the first general algorithms for computing and reasoning with uncertain evidence, allowing computers to uncover associations and causal connections hidden within millions of observations. His work has had a profound impact on artificial intelligence and statistics, and on the application of these fields to a wide range of problems in science and engineering.